when I did the regression on Desmos, this was the calculated Desmos one, it goes through a mathematical formula and finds the line that fits these points the best. It gives you the best fit line based on mathematics. Again, you do not want to do those calculations. I will just tell you that. But if you look at this, it's y, oh, that's not what I wanted. This is the slope. I'm sorry, I put the wrong thing. That's the slope. Now we came as 0.25. Their slope is really close to 0.2, which is really, instead of being 1/4, it's 2/5. Okay, we're very close. So our slope was about 0.25. It's a little higher than the 0.2 that they came up with, but not bad for eyeballing. Not bad at all for eyeballing, okay? The 1/7 is a little bit farther off. The 7/40 is probably a little closer to 0.2. I don't know what 7 divided, can somebody quickly do 7 divided by 40?
1.75.
1.75, so okay.
0.175.
So 0.175, so it's about,
1.75.
No, what?
no, it's not. Okay.
70 divided by 40?
7 divided.
7 divided by 40.
Oh, 0.7. No,
No.
0.175. Oh, I need to go to sleep.
0.175, that's what I said.
Okay, so again, it's not too far off from the 0.2 that they figured from the actual mathematical linear regression. A complicated path where you have to do a lot of work to get that, okay? Because that was a little bit smaller, they got a little bit smaller y-intercept of negative 322.933. So their equation, based on all the mathematical calculations, I'm running it to 0.2 because that's much easier for me, minus 322, actually I'm going to just minus 323. It's really not going to change it that much for that exactness, okay? So here is what they came up with as far as their formula, okay? And so if we did 2050 in there, y would equal 0.2 times 2050. Got your calculator out, Matt?
I think so.
Okay.
The ones we did it before.
Okay, Max?
Thank you.
I know you guys have them, I don't know anybody else's.
3, 4. Do you want to say Max?
It's okay.
345.
Wait, what do you mean?
87.
Yeah.
Can't be 304. Thank you, 87 sounds, so
I thought it was so
this
wrong.
may be,
What?
this may be a little bit more reasonable, because
Oh,
we're at 77 right now. I could see advancements, if we could cure cancer somehow, that would advance us a lot. If we could reduce obesity, that would help us a lot. If we could get some sort of artificial transplant stuff that we could use with cloning or that idea, which I am for that. I'm not for cloning people, but I'm okay with getting some sort of replacement or transplant thing that could help save a life. I'm for that. I think this is very doable in the next 25 years, okay, that we could be at this 87 years old for life expectancy. Okay. So that's basically some of the things that you can look at. But that's what they do in statistics to come up with predictor lines. But you have to remember that you have to have similar situations. You can't use it throughout history or predict it way out in the future, because you don't know what's going to happen in that time period. And so the farther you go out, the less accurate it's going to be. So if you're trying to predict in the next 10 years or 15 years or 25 years, it's probably going to be somewhat realistic. But as you get out farther, it's probably not going to be realistic.
Because pretty soon it's
Okay.
going to go start going down on like a stable level.
Well, actually, what happens in life is, who knows? We don't know. I mean, it
Maybe
was,
we are just gonna get older and older.
we could, I mean, I don't know. Or the new heavens and the new earth comes, and then we have a life expectancy of infinity, which you can't calculate mathematically. Okay, so how do you put that into mathematical terms? I don't know. Okay, so now what I want to show you is how to use a computer to do this. Okay, so please take out your computer. If there's one there at your table, then all of you look on one. I'm going to go through the steps so that you can go at home and use these steps at home. Okay.
Are we
So-
all done?
One, you're going to use Desmo. Go to Desmo's graphing calculator.
Yeah, man.
You have such pretty eyes.
I hear
I
that
don't
a
know
lot,
this
but never
table
from
anymore.
Max. You're the first, Matthew, thank you.
Okay. Is this table work together? Go over there,
Oh,
Max.
yeah,
Yeah, she has a computer. Who has the computer here?
we have no.
Nobody.
Oh, you got no computer.
Nobody.
Yeah, man.
I'm gonna bring my chair over here. Stop. Don't touch me like that.
No, don't touch me there. This is my no-no square.
Okay, I want you guys to all put together on this.
Cross.
I know. What? Not
We
you?
can scoot this
Or-
back.
Max, you can move over there.
Max?
Meg, you can move over there.
Don't yell at Meg.
And then somebody can push in, okay? So first thing you do is go to Desmo's graphing calculator. Just Google that and go to that.
I did the first step. You
Jump those.
I just typed in Desmos. Have some
No
patience.
internet.
Oh, are you
Wi-Fi
guys,
sound.
You have no patience, man.
is it still down?
Oh,
I
it's
think it
working.
just turned off.
It's working.
Ish.
I have patience, guys.
No, don't lie to people.
It'll go in and out. I hope this
It's
works.
that one.
I think it won't.
Well, then to press back.
I pressed
No.
No, because
You
now
said
you
You wanna
have to-
click that one.
I clicked this one?
Yeah, that one.
That's what I was clicking.
No, you
Yeah,
click
you
this.
wanna click it.
You guys on Desmo's?
Yes.
Okay, so up
No,
at the
Med,
top,
Med,
left
you,
hand
what
corner.
you wanna do? You wanna do is click it. See? He did it. He got it.
You didn't even click it.
No, we didn't. We're not on the right one.
there's
You just didn't write
Three
one.
lines.
3 lines like that. Click on that.
One right one. What was it?
Yeah.
Click.
Okay, scroll down that list. It should give you a list. Scroll down the list.
Click on that thing. And scroll.
Which one?
Scroll down the list.
To statistics,
Check.
Statistics.
Statistics.
linear
Linear.
That one.
This
regression.
one?
Regression.
This one?
I don't think
This one?
No, that one.
I know which one is it, Matthew.
Then why did you ask?
Then why'd you ask?
Because I was asking just in case you guys didn't know.
And click on that.
Definitely.
Oh, I did this step too
I
early.
played these games.
Wait!
Open, so if you look kind of in the middle, it will have something that's kind of like a graph, and it says open graph. Click on open graph.
You find that, Matthew?
Okay.
And then we're just gonna fill in our own numbers for X and
Where
Y.
are you open the graph? Oh.
Max, no going ahead now.
Okay,
I'm sorry, I'm just too smart for this.
on one side, it's gonna have an X and a Y thing where you can fill in numbers. Okay. When you fill in the numbers, make sure you've typed them in correctly. It will plot them on the graph over here, but if it's at 0, 0, your graph, you have to zoom in, okay? The way you zoom in is up here, there's a little wrench. I cannot draw a wrench, but it looks kind of like this,
I see some resemblance.
a wrench.
That looks pretty good.
And that wrench, when you click on it,
Wench.
basically wrench. There's an R.
Wrench.
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 Wrench. That's how it's spelled.
Wrench.
That's how it's spelled.
Food?
You will
R8.
see that it has what you want, like X's less than or equal to, less than or equal to. Put your two endpoints, like where do I want it to start and where do I want it to end. So in this last one for X, we went from about 1930 up to 2030 or 2020. So in here, you would put those two numbers. 1930 is the smallest, 2020 is the largest, because that will zoom you to those spots on the graph. Okay? For Y, it's going to have a spot. And we did in our graph, we went from 55 approximately up to about 80. So put our smallest, our largest. This will zoom in for the points, or to see the points that you've graphed. Now that's going to change.
Matthew, it's your turn.
Okay. Then you can see the graph. You'll see a line that they have drawn in. That is the best fit line. Okay. Then if you scroll down this direction,
Do what?
you will find an M and a B. It'll say linear line, etc., linear regression. It will give you an M and a B. And that M and B is the equation or the slope and the intercept for the line that fits your data the best. Okay, so I'm going to have you try this right now. I want you guys to try this. So what I'm going to have you do is open your book. And let me find my book. What did I do with my book?
And I'm guessing you want us to put in the years and the life expectation.
No, we're actually going to do a different problem.
Oh,
I already gave you the answer.
Next book.
So, that's life expectancy again. Let's do, on the graph on page 371, page 371, I want you to do the years and the all. And what these alls are is, let's do,
Doing what she told us.
no,
Not yet.
wait. You can pick either female or male. These are the female
You tell me when it's not
expectations,
coming in.
life expectancies versus the male expectations.
Alright, male.
So pick one of them.
Female will be Y.
So you're gonna put the years in and then you're either gonna do this
Okay,
column or
let's
this
do year.
column. Or this column, I don't care.
Year will
But
be
this one we already
1930.
did, so do one of the male or female.
1930.
So somebody enter the points, somebody read the points, and then see if you can find the line.
1960.
1960.
1970.
I got this.
1970.
1980.
1980.